Hi, my name is Anders and welcome to this breakout session on RedGrease. RedGrease is a Python client and runtime package for RedisGears that makes it easy to create and distribute computation on Redis clusters. In this presentation I will walk you through the motivation for creating this package, an introduction to RedisGears, how it provided a solution to my specific problem, an overview of the package, as well as a demo, and then I will round off with my own thoughts. As I mentioned, my name is Anders and I run a small business out of Singapore focusing on solution architecture, particularly in the domains of video analytics, biometrics, image processing, and event stream processing. So it all started with building a stream processing application. And this stream processing applications had a number of specific requirements. So first of all, it needed to be able to serve thousands of clients, not necessarily web scale, but still quite significant number of clients, but all using different technologies. So some clients were in Rust, some in Julia, some in Python, and some in JavaScript. And many of these clients had to do a lot of high velocity I/O with the application, in some extreme cases up to 50 megabit per second. And the application also needed to handle some complex event stream processing, such as aggregations and transformations in very near to real time. And there were some substantial low latency requirements as well. So due to this, it was quite early on quite clear that Redis might play a big role in the solution of this application. Of course, I had prior familiarity with Redis and a good experience, so that played an important role as well in the decision. And also the fact that Redis has a lot of clients already available, making the communication portion of all these different moving parts much easier, was of course very important as well. And the fact that it comes in both open source and enterprise version, giving flexibility for many different deployment scenarios is of course a bonus as well. And then, of course, we all know the performance and scalability, which is always very useful. So the initial approach was to create Redis modules. So Redis modules is basically a way of extending the feature set of Redis. By implementing a low-level C API that is provided by Redis Labs. So by using this, you can create your own packages and deploy them together with your Redis server, and this provides a lot of benefits. So you have data locality, you can do a lot of processing very close to the data, actually at the site of the data, and you can make quite a modular system whereby you offload a lot of the business logic from the client side or the consumer side to the service itself, and you can have very simple commands that they interact with. And of course you can achieve great performance thanks to both the data locality as well as the fact that it's a C API. Now, it does come with some challenges. For me specifically in the early exploration phase, when I wanted to try many different approaches and prototype different ways of addressing certain specific problems, it was a little bit cumbersome to use Redis modules. Partly because you need to compile a package and then restart and install, and you have to run, etc. And debugging was a little bit cumbersome. The experimentation aspect became a little bit of a hurdle. So it was not tractable for the initial phase of the project. So in comes RedisGears. So what is RedisGears? Well, RedisGears is a Redis module developed by Redis Labs, and I think it was introduced at RedisConf 2019, and version 1 was announced last year at RedisConf 2020. But basically it's a Redis module that allows you to send snippets of specific Python code to your clients, and it handles orchestration and distribution and execution of those functions in a scalable way on your Redis nodes. So some of the use cases that it allows you to do is to, one common use case is to put some of the caching logic inside the Redis cluster itself. So for example, one example that was presented last year was to have write behind or write through mechanics as a gear on the system. So the applications could write high velocity IOs to the Redis cache, and then behind the scene the gear itself would batch those and write them in batches more efficiently to high latency DB. You can also use gears to register to Redis and run them on specific events such as key space events and streaming process on streaming events, as well as also external events. So you can have an event-driven processing framework. And you can also use RedisGears to perform analytical queries of the map reduce type variety, which is not really the kind of thing that you would typically consider Redis for, but with RedisGears that's absolutely possible. And then there's also a very interesting example of AI serving on the Redis Labs GitHub that I think you should check out. It's quite interesting. So some of RedisGears features include running of these Python functions, special Python functions in batch, so on demand. But you can also register them, as mentioned, and have them execute on specific triggers, on streams, for example. And you can also construct these functions with the help of specific readers that reads the different types of data, the keys, streams, etc., etc. And you can compose operations that should be quite familiar to many of you, such as map, reduce, map, group by, and aggregate, which is quite similar to many other frameworks. And these operations can be parameterized with Python functions, which can include third-party packages that RedisGears will handle for you. So how did this give me a solution to my problem? Well, basically, using the command reader functionality of RedisGears, I'm able to use Python functions as stand-in for Redis modules. Basically, I could run the Python modules on demand using triggers from the clients, very much similar to a module, with very much the same benefits as well. I also have the processing on the server close to the data and the modularity, and of course using Python and its rich ecosystem and expressibility made it very powerful to explore. Of course, the performance is not the same as running a module in C, but still quite impressive, I would say. Anyway, this approach made it possible for me to iterate solutions very quickly. I could write early on a little script that monitored the directory, which I put my little commands in, and as soon as I typed a change, it was loaded into Redis and I could test it immediately. So basically the time between writing and testing was pretty much down to zero. I also created some helper functions and placeholders for the built-in runtime functions which were type annotated and with doc strings, so I could catch errors already at write time, so before even running them. Helps with the time system. And over the course of a few months, this little helper module and package, it was a module initially, it grew quite substantially. So eventually a client class was added with the full Gears command set, then a mechanism of executing Redis commands in a Pythonic way on the server itself, on the gears running on the servers, as well as creating gear functions without having to serialize strings, but basically create them by dynamically using objects, as well as a lot of different syntactic sugar and boilerplate utility functions, etc., etc. So it grew quite quickly over the course of a few months. But it was when I returned to Singapore from a travel in late January and had to be in quarantine for 2 weeks. And I couldn't work efficiently on my main project. So I took the opportunity at that point to say, hey, I can break out these gear-specific functionalities into a dedicated package and make it open source. And just in time for the Chinese New Year, the first version was released as open source, and it's now available under MIT license on GitHub. And even though it's not the main project I'm working on, it's something that I intend to continuously maintain and improve upon, and hopefully it should be much improved in the coming months as well. So now for just a quick demo, just to show you the features. So I'm just going to run through very high level 4 different pieces of demo here. So first, just running very quickly through the demos. I won't get bogged down into the details. You can always go back and look at the details yourself. This notebook is available on the GitHub page, so you can always look back. But then I'm going to look at the query example, where we do a complex query using RedisGears, and then a streaming example, as well as a custom command example. But starting with the basics. So instantiating a client object is very easy. Just import the RedGrease module and instantiate it as you would the normal Redis client, either for a single instance or a cluster. It works as expected. And then, of course, you have the normal Redis functions available for you, all docstring, then type annotated, etc., just as usual. But more interestingly, you have the gear-specific operations as well, and they're all under this gear property. So you have things like you can get information about the cluster. I'm not going to run them all, but you can also refresh the cluster, etc., and you can get statistics, etc. But maybe more interestingly is that you can execute the PyExecute functionality of the RedisGears, where you can execute these kind of command strings, Python command strings on the cluster. So this is one of the basic ones, which is basically the GearsBuilder here. Just iterates through the whole key space and just run here, returns it all in a batch. So if we run that here on our single instance, which contains only 3 keys, we will see that we get the whole key space here with the key name and the type and the value and everything. And then we can do transformations, such as here we do a map. We just take out the key and the record type, and we do export that as a tuple in batch as well. As you see, we get the same thing, but in a tuple format here. And you can do other things like count, which is also a core portion of the RedisGears framework. So all that is kind of vanilla RedisGears. But strings are quite tedious, and it's much nicer to use dynamic objects. So that's why RedGrease lets you create these functions dynamically using Gears function objects. So here we have a very similar function, but created programmatically instead, that takes all the keys and counts them in batch. So run here says that it runs in batch. And we can run that on our cluster here, and when we do that, we see that we have 5.8 million records in our database. Similarly, we can compose partial functions together using this programmatic approach. So here we have another function called images that basically iterates through the keys that match this pattern and extracts the value only. And then we have another one that builds upon that function and just adds a count operation. And yet another one which filters the original images by the ones that have the same value of the height and the width, i.e. square images. And then we have a fourth one which basically takes that one with the square images and selects 4 of them and extracts the URL component. So, and if we look at the type of this thing, it's basically partial function, so which is basically a programmatic version of the function. And of course you can use normal Python functions to create parameterized Gears functions. So here we have a function that creates a function that iterates over some records here, parameterized on a year here. And then you have a lot of different ways you can run these functions. So you can, I'm not going to go into all details, but all these Gears function can be run in many different ways. So you can look into that separately if you want. But for example, you can run it. The easiest way is the one showing here in the end, which is basically by having a Gears function here, and with the run command, you just add the argument on here and says which connection you want to run it on. So here we run it on the cluster, and this specific one takes the function we defined earlier with the 4 square images, and correctly here we see that it returns 4 square images. So the dataset we have loaded here, by the way, is a dataset called Coco dataset, which is a dataset of 250,000 odd images with annotations saying the objects that are in the images. So here, for example, this image would be have an annotation saying that there is a bicycle, and it would have another annotation saying that there is a car, etc., etc. So, with that in mind, let's say that we want to create a custom query, a query that where we can say different category of objects and how many we want or how many we don't want of that object, and it returns the images that matches those, that is annotated with annotations matching those requirements. So if we look here to begin with, just how a record is stored, right? So in this case, the records are stored in this kind of key format, and in each record, the annotations are hashes, and in each hash we have the image ID. We also have some identifier for the category and some other stuff here as well, right? So the first thing we want to do is just create a quick function that maps the names of the categories to the IDs of the categories, because they're just numbers. So here we can iterate through the value space of the categories, which is also a hash, just saying the name of the category and the ID and some other stuff. But here basically what we do is that we map out the name and the ID of each category, and then we just aggregate it by merging those dictionaries together. Quite straightforward. So if we do that, we also create the reverse dictionary here for lookup. But if we do that, we get something like this. So you see we have 80 different categories, and here's the mapping. So airplane is number 5, etc., etc. Okay, not so exciting so far. But basically, now what we can do is that we can take those instance annotations. We had a function, as you saw before, that we could get the annotations based on a specific years, because Coco datasets have been released in 2 batches, 2014 and 2017, with different annotations. So we can, with the function that we had earlier, we basically can get a Gears function that gives us the annotations from 2017. And then what we want to do, we can basically just run an aggregate by, which is a little bit like a combination of a group by, a map, and a reduce together. But basically, it lets us with one function specify what we want to group by. So we want to group by the image ID here, and then we can basically use an accumulator here. We're just going to use a dictionary. So for each image we have, so we take the annotations and we group them all by the image ID that they are annotated with, and then for each of those groups we run this accumulation function, with a dictionary accumulator, and accumulate the different categories. So the functions for that is up here. It's quite straightforward. You just add to the dictionary the category and increase by 1 every time we see it. And then aggregate by in RedisGears. It runs in 2 steps, one locally on each shard, and then it runs on top of an aggregation of the aggregations as well. So you have another function here that counts. Instead of getting annotations in, it gets the previous aggregations in. So instead of adding 1, we add the counts from the previous aggregation instead. So it's a 2-step thing, but it's pretty much similar to what we used to. And then we basically just format this to something a little bit more readable. And if we do that, we get let's see, it's right here. So we get something that looks like this. So for each image here, we get a dictionary of the different categories and how many we have in that image. So here we see, for example, in this image here, we have 2 zebras and a bird. Very interesting. Okay, so that gets us half of the way. So to continue, we have another function, basically. So here, so if assuming that our query object looks something like this, and we want to look for images that have these objects and in these quantities. So the first number would say the minimum number of objects, and the second would be the maximum. So here we would look for 1 or 2 images with 1 or 2 trucks, 5 or more bananas, exactly 1 person, and no oranges. So ellipses here, or the 3 dots, just means any number. So basically that would just mean creating dynamically based on this parameter a predicate function based on this, and then filter on that. So here we're creating that predicate function, and you can convince yourself that this is doing what you want, but it basically checks that for each of the constraints it's within the bounds for each of the images. And if we do that, we get something like this, and this is basically the result of that strange query up there. And you see that we have a few images, but it's a little bit hard to read. So we do one more function here, and we basically iterate through the different images, and we check that they are in that result. So the image ID is part of this result, is inside this result, and then we extract the URL. So if we do that and display it, we get something like this. Might take a little while, but it shouldn't take too long. So basically, yes, and we also get the images from the internet. So here we see indeed that we have images of a lot of bananas, up to 2 trucks. Yeah, here we have 2 trucks, and maximum 1 person, and we shouldn't see any oranges. Okay, so that shows that we can actually do complex processing, query processing with RedisGears. You can convince yourself that how it works by looking at the code later, but I just want to give you the gist here. Now an example of stream processing real quick. So basically, let's assume that we have some users that we store in hashes in Redis, and a user just has an ID, a balance, and a start balance. And then we want to do transactions of credits between the users simply by sending messages to a stream. So we just want to send to a stream here this transaction request saying that we want to send from this person to this person and this amount. And then we want the gear to basically sort it out and make sure that it happens without conflicts and without race conditions. So we create this helper function. This is just a function that sends the message, does nothing else, and randomizes the numbers. And then we have a number here to just show a balance sheet. So if we see here, we instantiate the 5 users and they have some kind of credit to begin with. This is the total number of credits available in the system, and this is the changes from the delta from the start, which is 0 in the beginning. Okay. So then if we want to create this gear that listens to the messages that are posted to the stream and perform the actual transaction, we can write a stream reader function, something like this. So we listen to a stream by using the stream reader, then we map an initialization function on top of it, and then we map another function that actually handles the transaction. And then we register this gear function listening to this streams, matching this key. And then we also can say that we want to batch it, but we want to have a timeout of 30 milliseconds in case we don't fill the batch within that time frame. So basically, just quickly looking at the initialization, we basically just take the message, the transaction request message, and populate it with some additional features. Most notably, we add a status pending here. And then the actual transaction logic is where the interesting happens, where we actually have, so this runs on the server, right? And with this context manager here, we can ensure that what happens in here is completely atomic. So we can check the balance, we can safely check the balance, and if it fails, we can just return, set the status to fail. But if it is okay, we have enough balance on the sender side, then we can perform the deltas and then set the status to successful. And then for good measure, we have a stream for each user to put their statements in there, like what transactions have actually happened. So if we run this, let's see, we register it first. So first, when we run it, we only register it, so we're not running it. So now we have a function that is registered, and it has been triggered 0 times, as you can see here. So now if we run it once, we can see here we have 1 transaction of 6 credits from user 3 to user 2, and the total number of credits in the system hasn't changed. But just to make it a little more interesting, here is some just a test to run 100 transactions in 100 batches in parallel, and we do that very quick. So if we run that and then look at the delta, let's see, it indeed has sorted out to be the transaction is sorted out. We don't have a delta, and we see that the function has been triggered a lot of times. And we can also see that the statement that we created to the statement for user 3 here, we can see that there's a lot of successful transactions, and maybe there's a failed one. No, there's no failed here because it's random, right? Okay, so for the last example, I'm just going to clear the database here. So we clear the registrations and the keys and all for the last example. And this is a very simple example, and just say where we want to have the caching logic of getting images as a gear on the client itself, so that on the server itself, so that the client just can ask for, give me this URL and ask to Redis, and Redis will look in the cache, and if it's not, it will find it, go get it outside. So we write this function which basically just looks in the so this is a function that runs on the server, and so it looks at the local key space if the URL is registered. If it is, it returns it. If it's not, it gets it and stores it and then returns it. It's a very simple caching mechanism here, right? Then we can actually register this function with a trigger using a command reader. So basically, when we call a trigger with cache get, it will trigger this function. So we can do this here. So for example, we can use the gears trigger with that cached get that we registered. I should register it, by the way. There we go. And then it will actually get the image data, and we can do this for all this URL. And if we do this real quick, we see that the images will roll in here, and you see that they are being actually fetched from the internet here, so they're running in decently slow, and eventually we will get so we get here, see that okay, this trigger actually ran 10 times. Okay, so now if we run it again just to prove, here we go, let's just run it again. Let's go here and do run again. Bonk. You see it's very, very quick now, so because it hit it in the cache. So that's not very surprising, but what's interesting here is that the mechanism for actually checking the cache and updating the cache is running on the Redis server itself. Of course, this was something similar to this. What was the cause of for me to create RedGrease? So there are some additional functions or sugar available for this kind of use case. So one of these is function decorators. So if you have the same function here, exactly the same function, no difference. Instead of doing all this gears, command reader, all that stuff, you can basically just decorate it with a decorator like this. And then, also instead of calling the trigger on the gears, you can basically just call it as if it was a local function. So this looks actually like we're doing a local call here, but what's happening behind the scene, thanks to the decorator, is that it's triggering the gear on the server and then doing the same thing and responding. So we will have the same kind of mechanism here. It behave exactly the same, but with different images. You see here, it's the cache is empty, so we get all the images are misses. But then eventually we will get to the end, and we will see that we have also triggered this new 43 here 10 times. So again, if we run it one more time, now the cache should be populated, so then we get these results very, very quick, and we see that the function has been triggered 20 times. So that's the demo, and please have a look at the notebook. It's available on the GitHub. So in conclusion, RedisGears is a very powerful way of let you run processes and batch processes and event processes on Redis clusters. RedisGears is an official module from Redis Labs. RedGrease, however, is a Python package specifically for RedisGears, and RedGrease makes development of RedisGears easier. And RedGrease is free and open source. There's a lot of features, and you can see, I'm not going to go through them again here, but it has a lot of different features, making life easier as a developer. And there's a lot of new features in the backlog that's hopefully coming soon, and hopefully a production-ready release will come not too far in the future. So it's on the way. Right now, the focus is on some bug fixing, testing, and documentation, but it's pretty close soon there. So keep an eye out for that. And of course, here are the resources where you can find more. So we'll look at the documentations, working progress on Read the Docs, and of course the GitHub repository. And the key takeaways, well, if you haven't tried RedisGears, try it out. It can get you out of a pickle, I'm sure. And also, of course, if you're running custom code on your database, be sure to take the additional security concerns into regard when you design such a system, because, of course, it comes with implications. And if you're already running RedisGears, please try RedGears. I think you might like it. And any feedback, any and all feedback is more than welcome. That's all from me. Thank you very much, and I hope you enjoyed it. Thanks.